Hi gang, this neat, very easy to make thing is called Franklin's bell. It's called that because in the 1700s, Benjamin Franklin arranged it so it would ring when a thunderstorm was on the way. In fact, it would sometimes ring even if there was just a dark cloud above. No illustration exists of his exact setup, but it was something like this. He had a metal rod, called a lightning rod, attached to the chimney on the side of his house. The rod's upper end was sharpened to a point. The lower end of the rod was connected to a wire that went through a wall, into the house, and down to a metal dome. Another metal dome was suspended close to that one. In between the two domes hung a metal ball. And lastly, the second dome was connected to earth ground. How did it work? The lower areas of storm clouds are negatively charged. Since like charges repel, that forces negative electrons in objects at the Earth's surface to be repelled downward, away from the cloud, leaving the surface positively charged. The same goes for the lightning rod. Since one of the domes is attached to the rod, those negative electrons go down to the dome, making it negatively charged. Also, since the top of the rod is positively charged, it attracts negative ions from the air, stealing their electrons, making the rod and dome negatively charged overall. Next, the negative charge on this dome repels electrons on the other dome, making it positive. Meanwhile, for the same reasons, the ball in the middle becomes negative on the side facing the positive dome and positive on the side facing the negative dome. While like charges repel each other, unlike charges attract each other. Depending on which dome is closest to the ball is attracted to that dome, for example, the negative dome. And when it hits, they make a ringing sound. Also when it hits, electrons move from the dome to the ball to even out the charge between the two. But that means they now have like charges, and so they repel each other. The ball swings away. Notice it swings away with a negative charge. The other dome is positive, and so it attracts the negative ball. When it hits, it makes another ringing sound. And again the charges even out, making the extra electrons on the ball go through the dome and to ground. That leaves them both with the same charge, and so the now positive ball is repelled back to the other dome, where the whole thing repeats. And it keeps repeating, as long as the rod keeps stealing electrons from the negatively charged air. So how does that apply to our homemade Franklin's bell? The bell part is the same. Electrons move for the same reasons from the negatively charged can to the tab and then to the other can, as the tab is attracted and repelled back and forth between the cans. The only difference is in what produces the charge, and where the electrons come from. In Benjamin Franklin's arrangement, the charge was produced by the storm clouds, and the electrons came from the ions in the charged air. Our homemade Franklin's bell uses a high voltage power supply instead. It can be a Van de Graaff generator, Wimshurst machine, normal kitchen implements, or one of many other devices. In the case of this Wimshurst machine, the charge is produced by the rotating discs and neutralizer bars. The electrons move to this collector, along this bar, and to the can. There they move from can to can via the tab. They then return to the disc via this other bar and collector. One last note, Franklin's bell was actually invented in around 1742 by Andrew Gordon in Germany, but it was Franklin who put it to this neat and novel use, and so nowadays most people refer to it as Franklin's bell. Well, thanks for watching. Be sure and check out my YouTube channel, rimstar.org, for more videos like this. That includes one called Franklin's Bell that shows you how to make your own and then how to use it. One about another fun, easy-to-make old science toy called a Faraday motor, invented by Michael Faraday in 1821. And one on how to make a jewel thief that lets you power an LED using a dead battery. And don't forget to subscribe if you like these videos, or give a thumbs up, or leave a question or comment below. See you in a bit.